Here we are still in section 3.3, only this time this is going to be video number 3. And we're going to be dealing with complex zeros in video number 3. So if you'll scroll all the way down to page 3-4, and we're going to talk about the conjugate zeros theorem. So the big deal about this particular theorem is if a plus bi is a 0, if a plus bi is a 0, then you automatically know that a minus bi, the conjugate, is also a 0. So that's a really big deal. If you're told a plus bi is a 0, then you automatically know the conjugate is also a 0. Little dude, this is not something that's in your textbook, but it is so helpful if you choose to memorize this. And so what you have here is that if you have to multiply two complex conjugate factors, okay, now I know that was a lot of words. You're multiplying two complex, they both have i's, conjugate factors together. If you have to do that, if you memorize that this is the same thing as x squared minus 2ax plus a squared plus b squared, that's going to make your life a lot easier. It's a lot less distributing. Okay, but you don't have to memorize little dude. It's just going to be easier if you do memorize little dude. All right, let's look at example 5. Notice that it says to find a polynomial function. So this is a lot like example 4 where we had to find a polynomial function. The difference, notice, is that one of our zeros is complex. Okay, so a couple things here. This says that we should find a polynomial of least degree. So I'm not told what the degree is going to be. And I'm told that we have a 0 at -4. All right, so a 0 at -4. And I'm also told that we have a 0 at 3 minus I. I like to write that again with an x equals 3 minus I. According to the conjugate zeros theorem that we just talked about, if 3 minus I is a 0, then automatically 3 plus I has to be a 0. So let's go ahead then. The first thing I'm going to do, even before I get my list of factors, is in preparation for using little dude, I'm just going to write down what is my a value and what is my b value. That needs to come from the zeros list. And so when you look at these two complex numbers, you'll notice that my a value is a 3. And my b value is either a 1 or a -1. And you'll notice that in a moment, that doesn't matter at all. All right, so we'll hold off on needing that in just a minute. And so let's go get our factors next. So our first factor is going to be x plus 4. Our second factor, remember that the way that you do this is you're going to take the 3 and the -I over to the other side so that it's along with the x. So we have a factor of x minus 3 plus I. And then the third factor will be x minus 3 minus I. All right, so let's take our 3 factors. We're trying to find a polynomial. So we're going to take our 3 factors and we're going to multiply them together. For now, they're going to be in factored form. Now, I told you that factored form I'm totally fine with, but you need to understand if your factors have imaginary numbers in them, you must multiply. And so I'm fine with factored form as long as there's no imaginary numbers in your factors. So the first thing that I'm going to do is I'm going to use little dude to multiply these two complex conjugate factors together. So little dude is right up here. I'll try to keep it uncovered. So I'm going to just leave my x plus 4 alone. Notice that you've got x squared minus 2a. A is my 3 that we found just a moment ago. X plus a squared is going to be 3 squared plus b squared. Now remember I told you that for the b it wasn't going to matter if I had a plus or a minus there, and that's because all I'm going to do with b is square it, so it doesn't matter which sign you keep on the b. All right, so we'll clean that up then just a tad. It'll be an x squared minus a 6x plus a 10. And then I need to go ahead, since I've already started multiplying, I might as well continue our multiplication. And so I'm going to multiply these two together, the binomial times the trinomial. Once again, I did not show my work on this. This is previous material. If you need a shortcut, or not necessarily a shortcut, but if you need a trick for making fewer mistakes on all this distribution, just text me or email me or leave me a comment in the video, and I can give you one little trick that can help with making mistakes on that distribution. But I just went ahead and I distributed on another piece of paper and just transferred it over to here. So the polynomial function that I have is x cubed minus 2x squared minus 14x plus 40. It did not say anything about a leading coefficient, so we're going to just keep a leading coefficient of 1. All right, then let's take a look at the zeros of a polynomial function. So this is example number 6. It says to find all zeros given that 2 plus I is a 0. So the first thing that we're going to do is we're going to start making a list of our zeros. And since 2 plus I is a 0, the conjugate zeros theorem says 2 minus I automatically has to be a 0. So the first thing that we'll do is remember that when you're told what a 0 is, you want to prove it. We did that earlier in one of our other videos in this section. So just prove that it truly is a 0. Prove that your remainder equals 0. So I went ahead and I set up the beginnings of my synthetic substitution. You might want to go ahead and pause your video, see if you can do the synthetic substitution on this one and get the same thing that I get. So once I have done my synthetic substitution, I do find that my remainder is 0, which is what I expected. In fact, if I get anything other than 0, I should start over again because I've done something wrong. And that takes care of this first 0. Now to take care of the second 0, I'm going to plug this into the depressed polynomial. Plug it into the depressed polynomial. We did this earlier, once again, in another video in this section. Do not go back to the original for this. It will make your life much more difficult. So once again, I would pause the video, see if you can get the synthetic substitution on this. You should get a 0 remainder. So as I uncover then my synthetic substitution, we did get a 0 remainder. This is exactly what we expected to find. All right, so now what you notice is that my leftover depressed polynomial is a quadratic. We know how to solve quadratics. So the first thing that I'll do is just simply write it as a quadratic, and then I'll use factoring to solve. And so then I have that my zeros are x equals -5 and x equals 2. Notice that the only thing I was asked to do on this example was simply to find the zeros. I was not asked to factor or anything like that. I was only asked to find the zeros. So at this point, I've done everything that I was asked to do. And this is going to be the end of this video.